Welcome back. In this video, we are going to solve example 6.3 that is taken from chapter number 6, Bending, and book name is Mechanics of Material by RC Hibbeler, 9th edition. So statement is draw the shear and moment diagram for the beam shown. So you can see this is simply supported beam having a distributed load acting over the length of 18 feet, and we will divide this distributed load into a triangular load plus there is a rectangular load. So let's start with the solution. So first step is that if you remove this support, roller support at this point, let this is point 1, so we'll having reaction force which is R1, and if you remove this pin support at this point, let this point is point number 2, so you will be having a reaction force which is R2y, and there will be a horizontal component which will be equal to R2x. So we'll find this R1, R2y and R2x by using equation of equilibrium. But first we will divide this distributed load first into a rectangular load. So you can see whole this shaded portion is rectangular having magnitude of 2 kips per feet, and then there is a triangular load. You can see this blue color, this one is in triangular region. Let me draw it again. Okay, so this triangular is, now the magnitude here will be equal to 6 minus 2 will give you 4 kips per feet. Okay, and again we will divide, we will convert this distributed load. When converted it into a point load, so it will be act at the middle, and this magnitude will be equal to 2 multiplied by the length over which it acts, which is 8. So that will be equal to 18, not 8, 18. So 2 into 18 is 36. This is 36 kip load. And this blue color triangular load, when converted into a point load, so I will write it over here, it will be equal to 1 over 2 multiplied by this 4 and the length over which it acts, which is 18, and that will act at a distance of L by 3 from this side. So L is 18, so 18 by 3 is 6 feet. So 6 feet from this side and 12 feet from this side. Okay, and the distributed load, since it is acting at the mid, so it will be at a distance of half of the 18, which is equal to 9 feet. Now we can apply the equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right is taken as positive. So from this you can see only the horizontal force, which is R2x, is acting. There is no other force, so it means that R2x is equal to 0. Now we will find the second force by using equation of equilibrium, that sum of all moment about point 2 is equal to 0 and taking the counterclockwise moment as positive. So about this point 2, first moment will be this R1 into perpendicular distance is 18, and this is producing clockwise movement, so it will be negative. So I can write it as minus R1 times 18. The second force that is producing movement is this 2 into 18, and perpendicular distance will be this one, which will be equal to 9 feet. And this is producing counterclockwise movement, so it will be positive. So I can write plus 2 multiplied by 18 into 9. The last force that is producing movement about point 2 is this force multiplied by perpendicular distance is 6, and this is also producing counterclockwise, so it will be positive. So I can write plus 1 over 2, 4 multiplied by 18 into perpendicular distance 6 is equal to 0. Now we will get minus 18 R1 plus 2 multiplied by 18 multiplied by 9 is 324. So 324 plus 4 into 18 multiplied by 6. 4 into 18 multiplied by 6 divided by 2 is 216 is equal to 0. So 324 plus 216 plus 324 is 540. So it means that 18R1 is equal to 540. So if you divide this answer by 18, you will get 30. So from here R1 is equal to 30 kip. Now you have this R1, so we will find this R2y by using the third equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see R1, which is plus minus this 36 minus this 4 multiplied by 18 divide by 2 is 36. It is also 36. So minus 36 plus R2y is equal to 0. So from here you will get this 30 minus 36 minus 36 is 42 minus 42. So R2y will be equal to 42 kips. Now you have all these three reaction forces. So what we will do is that if I copy this diagram over here, let me copy it and I will paste it over here. So you can see that if I section it at a distance of x, at any distance which is x, let me call this distance as x, and x is greater or equal to 0 and less or equal to 18 feet. And if I draw the free body diagram, so it will be like this. Let me draw it first here at this is your point 1 where you have R1 and R1 was 30 kip, and this distance where we cut the beam is x. Clear? And you can see you have a distributed load plus a triangular load. So this distributed load is 2 kips per feet. And what about the distributed load over here? Since we have 6 feet or a length of 18, so if I take 6 divided by 18, that will be equal to W divided by X. So from here we will get this W is equal to 6 by 18 multiplied by X. Okay, not 6, sorry. This was, the remaining was 4 kips. So correct it. So this is 4 feet. Let me take it. This was 4 divided by 18 divide is equal to W by 6. So 4 by 18. So we will get W will be equal to 4 by 18 into X. Okay. So what we will do is that we will convert this distributed load into a point load. So it will act at the middle of this beam, and that will be equal to 2 multiplied by the length over which it acts, and the length is X. Now here W is equal to 4 by 18 times X. So when this triangular load is converted into a point load, so it will be equal to 4 into 4 by 18 into X. This is the magnitude, so 1 over 2 into magnitude, and the X is the length over which it acts. So when you cut it, you will be having a shear force V, as well as you have a reaction moment at the section where you cut it. Okay, this is M. So we'll find this V and M by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see 30 kips is upward. So 30 minus this 2x which is acting downward, so I can write minus 2x minus this load which is 1 over 2 multiplied by 4x square divided by 18. Clear? That is minus v is equal to 0. So as we are interested to find out v, so v is equal to 30 minus 2x, and this term 2 will cut with this 4, so 2x square over 18, so it will give you x square over 9, and the unit of this equation will be in kip. That this is your equation number 1. Now we'll find this m by using equation of equilibrium, that sum of all moment is equal to 0 and taking the counterclockwise movement as positive. Since we are taking it at a point and that is 1, so we will take sum of all the moment about point 1 is equal to 0. So starting with the first load, which is 30 kips into x, about point 1 is producing clockwise movement, so it will be negative. So I can write minus 30 into x. The second load which is producing movement is 2x, and since this is a point load due to this distributed load, so it will act at a distance of x by 2 from this point 1, and that is producing counterclockwise movement, so it will be positive. So I can write it plus 2x, and perpendicular distance is x by 2. Let me write the perpendicular distance for that. This distance is x by 2, and for this triangular load, this distance will be equal to x by 3 from this side. Okay, the last load that is producing movement is this load, and perpendicular distance is x by 3, and this is also producing counterclockwise movement, so it will be positive. So I can write it plus 1 over 2 4 by 18 times x into x, and perpendicular distance is x by 3 is equal to 0. Okay, not 0. We have left the one term which is this moment term. You can see, and this counterclockwise movement is taken as, and their sum must be equal to 0. So from this we will get movement will be equal to 30x minus x square, and this 2, it will be 2 will cut with this, so 9 minus x cube over 3 8. Okay, x by 3, so it will be 2 into 9, and 3 9s are 27, and this will be the moment equation, and the unit will be kips into feet. This is your equation number 2. If you want to check whether equation number 2 is correct or not, so we know that this shear force is equal to dm over dx. So if you take derivative of this equation, dm over dx, so it will be equal to 30 minus 2x minus 3x square over 27, which will give you 30 minus 2x minus x square over 9, and that is equal to shear force, and which you can confirm from equation number 2. These are same, so it means that your equation of the second equation number 2 for the moment is correct. Now moving to draw the shear force and bending moment diagram, what we will do is that we have both the equation, so we will draw a vertical line from the end of these beams, and first we will draw the shear force and then bending moment diagram. So for that I am drawing a horizontal line that show you x in feet, and on y-axis you have shear force having units kips. Okay, let we take one division is 15 kips, two division is 30 kips, third division is 45 kips. There similarly minus 15 minus 30 minus 45. Okay, starting with this equation number 1, I will take the help from the calculator. So if you want to solve it, so you have to go to the table, you have to write the equation. The equation was 30 minus 2x minus x square square divided by 9. Okay, so this is the equation, and we will put the value of x is 0 and the second ending value is 18 feet. 18 feet, and we will go in one step. So you can see, okay, so you can see at x is equal to 0 you have 30, and at x is equal to 18 you have minus 42. You can check it for x is equal to 0, and you can get different values. At x is equal to 127.88, at x is equal to 225. So you have all these values, you can just plot it. I will draw direct 2 points and we will see what we will get. So at x is equal to 0, put in equation 1, we will get v is equal to 30 kips. And at x is equal to 18 feet, put in equation number 1, we get v is equal to minus, let me check it, minus 42 kips. 42 kips. Okay, so for plotting, first we will plot at x is equal to 0. We have first point is this one, and at x is equal to 18. So we have minus 42 kips. Okay, now you can see that we do not know in between these 2 points. We know that our shear stress will be 0. That is in between 9 and 10. The shear force comes down towards 0. So for finding that, for x at which shear force is 0, so we will take this equation 1 equal to 0. So this is equation 1. So v is equal to 0 is 30 minus 2x minus x square by 9. So rearranging it, we will get minus x square by 9 minus 2x plus 30. So by using calculator, we will solve this quadratic equation. So go to the mood, then go to the solve the polynomial degree 2, and then just put the value of this minus 1 divided by 9 is the value of for A. For B we will have minus 2, and for C we have plus 30. So when you solve this, you can see x, one of the root is 9.734 and the second is minus. So we will neglect the value. So we will choose the one root. X will be equal to 9.735 feet. Okay. So at this point, we will see that what is the value of this shear force. So at x is equal to 9.735 feet, we'll choose this, put in equation 1, we will get v is equal to 0. Now by using these 3 points, one is this one, second is this one, and third is this one. So we will draw the shear force equation. So v is equal to 0 at 9.735. So let 9.735 is there, 9.735. So again you can see this loading distributed load is the combination of this uniformly distributed load and triangular load. So we will get the curve like this. It will be not a straight line, but it will be like this. and from this you will move in curve form. Okay, so this is your shear force diagram. This distance is 9.735 feet, at which shear force is equal to 0, and that is shear force diagram. Now we'll move toward the bending moment diagram, and for bending moment diagram I will draw a horizontal line for x in feet, and on y-axis you will have a moment, and let each division is 50. So 50, this is 100, this is 150, and this is 200. Okay, we have the equation for the moment is this one. You can see this moment equation is, so for we will find for moment x is equal to 0. So if you put this x is equal to 0, so all the term will be 0. So we will get moment will be equal to 0. And for x is equal to 18 feet, put in equation number 2. So when you will put it in equation number 2, you will get this moment will be also equal to 0. And at x is equal to 9.735 feet. So when you put it in equation number 2, so you will get moment will be equal to 163 kips into feet, and that will be the maximum bending moment. Why this is maximum? Because the region at which shear force will be equal to 0, you will get the maximum bending moment. So plotting this point at x is equal to 0, you have moment is equal to 0, and at x is equal to 18 feet, you have moment is equal to 0. And for x is equal to 9.735, we have moment is 163. Let this point is 163 kips into feet. So if you plot it, it will be a curve like this, clear, and you will get a curve like this, which will be your bending moment diagram. So this was all about this example 6.3. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.